All right, so in the previous slides, you should have written down the definitions for heat capacity and specific heat, also known as specific heat capacity. All right, so the definitions might have been kind of confusing, but I'm going to summarize and clarify them in this video. So rather than talking about the definitions, I think a lot of us have an understanding of heat capacity and specific heats, and let me show you how. So for example, instead of talking about the different definitions, what if I asked you this? Which gets hotter on a hot day? So let's say both of these seats were in the sun for 1 hour. So I have a cloth seats and a leather seat. Which one would be hotter after sitting in the sun for 1 hour? I'm guessing a lot of you are going to say leather seats, right? So leather seats have a lower heat capacity or specific heat than cloth seats. So basically, what this means is that leather, when I say has a lower specific heat, means it just gets hotter faster, right? Anything with a higher specific heat will get hotter slower. So looking at this table, right, things that have a bigger number for specific heat take longer to heat up, right? Things with a lower number or a lower specific heat get hotter faster, right? And if I look at the examples like aluminum, so I'm guessing y'all have a pot at home and you probably maybe have boiled some water in a pot before. So you might have noticed that the aluminum pot, the pot itself gets hotter before the water gets hotter. And that's because water has a higher specific heat, right? Meaning it takes more energy to heat up water than it does to heat up aluminum. Aluminum will get hotter faster, right? So the only difference with the formal definitions is that it's talking about how long does it take or how much energy does it take to raise the temperature of the objects by 1 degree Celsius, right? So the bigger the number, the more energy it takes and the longer it takes for it to get hotter faster, right? So heat capacity is how much energy it takes to raise it by 1 degree Celsius. Specific heat, the only difference is that we care about the mass of the objects. So for all of these are all the specific heats. So when we tested this out, we used 1 gram of every single object. So this is how much energy it takes to heat up 1 gram of all of these objects by 1 degree Celsius. So that's what it means by specific heat. All right, so let's talk about how we would use this in an example. Right. So oftentimes I will give you the specific heat of two different substances. So the specific heat of water is 4.18 kilojoules per kilogram per degree Celsius. So this unit just means that it takes 4.18 amount of energy to heat up 1 kilogram of water by 1 degree Celsius. This unit means that it takes 1.67 amounts of energy to heat up 1 kilogram of oil by 1 degree Celsius. So looking at these numbers only, can you tell which gets hotter faster? All right, so I'm not going to tell you the answer just yet. We're going to do an experiment to see if this is true. So notice that both of them start at the same temperature. One is water, one is oil, and we're going to heat these both up at the same time to see which gets hotter faster. So looking at the temperature scale, right, next to each substance, can you notice which one's getting closer to the top of the thermometer? Maybe you notice that olive oil is increasing in temperature faster than water, right? So olive oil gets hotter than water faster, right? So going back to this, olive oil has a lower specific heat than water. So as mentioned before, it's going to get hotter faster. Right. Now moving to iron and brick. So brick has a specific heat of 8.4. iron has a specific heat of 4.49. Now knowing this, can you guess which will get hotter faster?